Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is the coordinate geometry. Still, we are learning how to write or how to find the equation of a straight line. This time around, we take the last form, and this last form is called the intercepts form. So let's begin. After completing the very lesson today, my dear student will be able to find the equation of a straight line using its intercepts on x and y axis. So if you have the intercepts on x and you have the intercepts on y axis, this you'll be able to write the equation of that very line. So this is what I hope you'll be able to do after completing the very lesson today. So as usual, your math segment, math is fun. Today I'll still give you another interesting and amazing property of the Pascal triangle. This is property number 5, which is still amazing. You see this property after completing the very lesson today, so stay with me. So to begin in the lesson, let's learn what to do if we have the intercepts on x and y axis that the line passes through, and we are asked to write the equation of that very line. So it says our equation of a straight line crossing the x-axis and also crossing the y-axis at A and B respectively. So A is the point where the line crosses x-axis and B is the point where the line crosses y-axis. As you can see here displayed in this very drawing, this is the y-axis and this is the point where the line crosses the y. It is the point B. And this is the x-axis, and it is there at the x-axis, the point A where the line crosses the x-axis. So if you have this and wanted to write the equation of that line, that is, you have 2 points where the line crosses x and y axis. So the equation of that very line is given by this simple formula: x over A plus y over v equals to 1. This is what you now do. When you now substitute and simplify, what you have in the end will now be the equation of that very line. We are going to take an example how we can make use of this very simple formula to write or to arrive at the equation of the line. So example number 1, it says find out the equation of the line crossing x and y axis at 3 and minus 5 respectively. So 3 is the point where the line crosses x-axis and minus 5 is the point where the line crosses y-axis. Solution to this very problem, we write down the formula. Remember, it says x over A plus y over B equals to 1. So your A is the point where it crosses x-axis. In this case, it is 3. And your B is the point where the line crosses y-axis. In this case, it is minus 5. So substituting there correctly, you now have x over 3 plus y over minus 5 equals to 1. So what we now do, we clear this fraction by multiplying each and every term by the LCM of the denominators. My denominator here is 3 and 5. LCM will be 15. So multiplying each and every term by 15, you now have x over 3 times minus 15 plus y over minus 5 times minus 15 equals to this one by the right hand side times minus 15 as well. So I continue. So there 3 will now go into this 15, 5 times. So you have 5 times minus 5 times x, that gives you minus 5x. Y over minus 5 times 15, minus 5 in minus 15, it will give you 3. 3 times y gives you 3y. And y times minus 15 simply gives you minus 15. So we continue. So collecting like terms there, or dividing both sides by this, you now have minus 5x shifted to the right hand side. There you have 3y equals to 5x minus 15. And this would now be the equation of this very line. So let us move and take another example. Example number 2, it says find out the equation of the line crossing the x and y axis at 1 and 6 respectively, which means 1 is the point where the line crosses x-axis and 6 is the point where the line crosses y-axis. So solution to this very problem, we write down the formula is this: x over A plus y over B equals to 1. So substituting A by 1 and B by 6. There you now have x over 1 plus y over 6 equals to 1. So next is to clear this fraction by multiplying each and every term by the LCM of the denominators. In my denominator, C is 1 and 6, LCM will be 6. So each and every term here multiplied by 6. There I'm going to have x over 1 times 6 plus y over 6 times 6 equals to 1 times 6. So x over 1 times 6 will give you 6x. And y over 6 times 6 will give you 1. It's simply 6 into 6 is 1 times y is 1. Y there. And 1 times this 6 gives you 6. So you can now collect like terms. This 6x shifted to the right hand side there to change it to minus. So you have y equals to 6 minus 6x. This is now the equation of this very line. And with these two examples, I have come to the end of this very lesson, my dear student. I hope with these few examples, you'll be able to write the equation of a straight line if that line passes through the two axes, x and y axis, and you have the values where the line crosses the two axes. Thank you for your attention, and let me just to move to the last segment, Maths is fun, and give you the fifth property of the Pascal triangle, which is indeed interesting. So interesting property of the Pascal triangle number 5 is says the third line diagonal down to either left or right, that diagonal line contains a triangular numbers. Let's see, this is the diagonal down, the third one, and this is another third diagonal down. So these are the two lines diagonally down. It is this and this contains this numbers 1, 3, 6, 10, 15, 20, and 28. It is this numbers, look at them, 1, 3, 6, 10, 15, 21, and 20. They are called triangular numbers because simply if you have just a number of balls exactly equals to the number there, like here is one ball, you just have one. Here is 3 balls. If you can arrange these balls, you have something like this, which form a triangular pattern. Similarly, you have 6 balls. You can arrange them with 3 at the bottom, 2 at the top, meaning the second row, and 1 at the extreme top there. This form a triangle. If you have 10 also, you can use those 10 balls to form triangular arrangement with 4 at the extreme bottom, 3 next, 2 next, and 1 at the top. This form a triangle. Similarly, 15, you can form a triangular pattern of numbers using 15 balls. Similarly, you can use 21 volts to form this triangular arrangement of balls there, and the 28 as well, triangular number. This is amazing. We see more of this interesting property of the Pascal triangle in our next lesson. Thank you for your attention.